Okay, example 2 from 5.5. We're doing double angle identities. So this time we're looking for the values of all 6 trigonometric functions, given that cosine 2 theta equals 4/5. So this time they gave us what a double angle equals. So remember, with cosine, we have 3 different choices. In this case, I could use either this one or this one, since I don't know what just regular cosine is. So I can use my cosine 2a to find either sine or cosine. And it doesn't matter which one. So I'm actually going to use this one right here. I'm going to use 1 minus 2 sine squared a. All right, so let me scroll back down here. All right, so here's my identity. Cosine of 2 theta equals 1 minus 2 sine squared theta. All right, so I know that cosine theta is 4/5, so I'm going to replace the cosine 2 theta with 4/5 because they are equal. So it's just substitution. And that gives me 1 minus 2 sine squared theta. So now it's just an algebra problem. I'm going to subtract 1 from both sides, which really that's 4/5 minus 5/5 is going to equal negative 2 sine squared theta. So that's negative 1/5 equals negative 2 sine squared theta. All right, so we're just doing algebra here. So I need to divide by negative 2. And if I divide the right-hand side, I have to divide the left by negative 2. And dividing by 2 is the same thing as multiplying by 1/2. And it just happens to be negative this time. So that would give me positive 1/10 equals sine squared theta. But I'm not looking for sine squared theta. I need to know sine theta because I'm looking for the 6 trigonometric values. So I take the square root of both sides. That would give me the 1 over square root 10 is sine theta, which we do need to rationalize that. So that would be square root 10 over 10. All right, now it did tell me up here that we're looking for theta between 90 and 180 degrees, which means we're in quadrant 2. All students, which means that sine is positive, so that's my sine value. And I can easily find my cosecant value by flipping this over. So I now know sine and cosecant. Cosecant of theta equals square root 10, because I just take this and flip it. All right, now I know sine. So I know sine theta is square root 10 over 10. I could use, now that I know sine theta, I could use any identity I want to find cosine theta. So let's just use, I could go back and use my double angle identity if I wanted to do that. Or I can use sine squared plus cosine squared equals 1. So that's what I'm going to use. So if I do sine squared plus cosine squared equals 1, I get 10 over 100 plus cosine squared theta equals 1, which means I'm going to subtract 10 over 100 from both sides.
So I end up getting cosine squared theta equals 90 over 100. Take the square root of both sides, and you get cosine theta equals square root 90 over 10. Square root of 90 breaks down 3 square root 10 over 10. And you can flip that and rationalize it to find secant. And then I can also find tangent easily, because remember, tangent is always, let me switch colors so that I'm doing it in a different color. Let's see, let's do blue. So tangent is always sine over cosine, and sine is square root 10, and cosine is 3 square root 10, which means those two cancel, and I get 1 over 3. Now the only thing I need to check, which means that cotangent is 3, but remember, we are in quadrant 2, and the only thing positive in quadrant 2 is sine and sine's buddy, cosecant. So these two right here are positive, but tangent is negative, cotangent is negative, cosine is negative, and secant would also be negative. And that is